Welcome! In this video, we will be exploring the procedure for setting the neutral plane of a conventional DC machine. As you will recall, the neutral plane describes the relationship that exists when the armature windings are moving parallel to the magnetic field of the pole pieces. The neutral plane could also be described by the perpendicular orientation of the armature windings in relation to the magnetic field of the pole pieces. Regardless of which explanation we use, both refer to a point in which the armature windings cut through minimal magnetic flux created by the pole pieces. The process of setting the neutral plane refers to positioning the brushes so that winding commutation occurs when in the neutral plane position. Remember, commutation occurs when one winding is disconnected from the outside circuit as the next winding is connected to the outside circuit. The reason for setting the neutral plane is to ensure that commutation occurs when windings are cutting minimal magnetic flux and therefore are experiencing minimal induced voltage. If commutation occurs outside the neutral plane, the induced voltage present on the winding produces arcing and sparking, which will degrade the brushes and the surface of the commutator. The following electrical test involves energized equipment. Even though the voltage levels are below 50 volts, a high degree of caution should be observed. The neutral plane of a conventional DC machine can be set by applying the following procedure. First, connect the armature to a variable AC voltage source. Second, connect the digital multimeter set to measure AC voltage to the shunt field. Third, turn on the variable voltage source and adjust it to apply a low voltage. Around 10 to 15 volts should be sufficient for a small DC machine such as the one in this video. Carefully adjust the position of the brushes while observing the reading on the multimeter. Adjust the brushes until the meter reads the lowest possible value. Once the lowest possible value has been reached, the neutral plane of the DC machine has been set. At this point, you can turn off the variable voltage supply and disconnect all your test leads. Understand that during this test, the armature of the DC machine is being turned into the primary winding of a transformer. The shunt winding acts as the secondary of the transformer. When the brushes are connected to windings that are not in the neutral plane position, the AC voltage applied to the armature causes a voltage to be induced onto the shunt winding. When the brushes are connected to the windings that are in the neutral plane position, the AC voltage applied to the armature fails to cut across the shunt field windings. So, you should now have a better understanding of how the neutral plane of a conventional DC machine is set, as well as how to apply a simple procedure to set the neutral plane. See you next time.